Relay drivers make dealing with relays an easy job, especially when using them with microcontrollers. So, I thought the best way of learning their working principle is making one with a different design. In this video, I will show you the steps I went through while making a relay driver and some important concepts that may help you in your electronics project. So, without any delay, let's start our video. Relay is a controlled mechanical switch that provides isolation to your circuit. And to control it safely with a microcontroller, it is recommended to be used with a driving circuit. But before anything, let's take a look at the working principle of relays. This is the internal circuit of a relay. So, when energizing its coil, you will hear a sound, meaning that the switch has moved from normally closed to normally opened pin. Boom, that's it. After having an idea about relays, let's have a look at its driving circuit. As you may have noticed from this circuit diagram, when applying logic 0 to active low node, the gate of the PNP transistor will be derived to ground, leading it to be turned on, allowing the current to pass from its emitter to its collector, which will energize the relay coil and turn on the red LED. On the other hand, when applying logic 1 to active high node, the NPN transistor will be activated, which will drive the PNP transistor gate to ground. This will turn it on. So, this will do exactly what applying logic 0 to active low node does. Well, obviously, when the relay switch is on, the green LED will light up, indicating that the relay switch state has changed. But wait a second, what's the purpose of this shunt diode then? This is actually called freewheeling diode, and its purpose is to provide a discharging path for the relay coil to discharge its energy when the voltage potential across it is removed. This procedure works as follows. When the potential across the relay coil is removed, the coil itself stores its energy for a time, since the current in the coil doesn't change instantaneously. Instead, it decreases with an exponential decay, like the graph shown. And from the inductor voltage formula, the voltage is equal to the inductance times the current change rate. This will give us a negative voltage, since the current amplitude is decreasing. So, this will form a reversed voltage across the relay coil when de-energizing it, which will harm other components in the circuit. So, adding a parallel diode to the coil will remove this reversed voltage. This technique is very common and you may have seen it in other circuits. Having completed the theoretical part, let's do something practical. Here I have constructed the circuit I have discussed to test the functionality of active low and active high feature of the driver. After that, I've used STM32 microcontroller to control the relay driver by generating an interrupt that changes B9 GPIO pin state when a falling edge at B5 pin is detected. And here's the result. This is actually a way of turning push button into on-off switch. And here is the circuitry I have used to make triggering falling edge interrupt work properly. But what is the purpose of this shunt capacitor for such a simple circuit? Well, this will be the topic of my next video, so make sure that you smash the subscribe button even before finishing watching this video. Before putting everything together on a breadboard, I decided to change the place of the red LED so that it indicates that the driver is connected to a power source. Well, usually relays are used to control AC operating devices, but I didn't do this in my video since the purpose of my video is educational. To make this project permanent, I soldered the required components on a breadboard to make use of it later on. But remember to glue the connection side of the board after making sure that it's working properly to avoid unwanted short circuits in the future. As a final test, I mounted a buzzer on the output terminal of the board and tested both active low and active high pins to check if everything is okay. And here is the result. This brings us to the end of this video. If you like what I'm doing, please support my channel by clicking on the subscribe button and sharing this video. Your support motivates me to continue sharing more content. Thank you for watching and see you next time.